Hello friend, welcome back to Get Up. My name is Vikas. In my previous video lecture on engineering mechanics, we have studied about kinematics of rigid body and particle. Okay. So in today's video we'll be studying about the kinetics of particle and rigid body. So as you know the difference between kinematics and kinetics. In the kinematics we studied the motion without considering the cause of the motion. Okay. That is, we only studied about the motion in terms of the velocity, acceleration and the displacement. But in today's video lecture, we'll be studying about kinetics. So kinetics will be studying about the cause of that motion, which is force along with the torque or the moment. Okay. So we'll be studying about these things in this video lecture. Okay. So the kinetics is the study of the effect of the forces on the particle, motion along with the considering the cause of motion, that is force and torque. Okay. Now, as we have studied in the previous video lecture, that the motion of the particle will be studied in either rectilinear motion or curvilinear motion. So, as you know that the motion along a straight path is called a rectilinear motion, and if the particle is moving along a curved path, then it is called curvilinear motion. So, this is we have already studied in the previous video lecture. So, today we are not going to discuss about it. Okay. Now, let us see the equation of motion in rectilinear motion or rectilinear path. Okay, what is the equation of motion? Now suppose that there is a particle P. Okay, now on this particle some forces are acting. Suppose this force is acting on this particle F1 and F2. Okay, now this the equation of rectilinear, according to equation of rectilinear motion, since this force is acting, these two forces are acting on this particle. Okay, so this particle will also have some motion. Suppose this motion of the particle is having some acceleration A. Okay, so the resultant force acting on this particle will be equal to product of the mass into the acceleration. Okay, so this is the equation of motion, or you can say equation of rectilinear motion. Okay, now there is a principle called D'Alembert principle, which gave you the equation of dynamic equilibrium. Now since we have studied that summation of the forces acting on a particle is equal to product of mass and acceleration. So what does D'Alembert principle tells us? That this force, as you know, this is the external force resultant of the external force acting on the particle. Okay, and this is the force due to inertia. Okay, so if we bring it out here, okay, minus of ma equal to 0. This can be written like this. Also we can write it summation of F external forces plus minus of ma equal to 0. So we can write this like this. So D'Alembert principle says that the net force acting on a particle is the sum of the external forces acting on the body or the particle, along with that the inertial force acting in an opposite direction of the external force. Okay, this is the inertial force acting in a direction opposite to the direction of the acceleration. Okay, so that's why there is a negative sign here, and the summation of these two forces is equal to 0. This is nothing but called D'Alembert principle. Okay, so if we resolve these forces, suppose this was the resultant force acting on that particle that we discussed in the previous slide. Okay, so it will have two components, one component in the x direction and one component in the y direction. So we can also say that if this is the case, that means that this mass of the particle which was having some acceleration, net acceleration, will also have two components of acceleration in the x direction and the y direction. Okay, so whenever there is a resultant force, there will be two components of acceleration in case of rectilinear motion, and those components of acceleration will be in the x direction and y direction. So we can also write the equation of motion. Okay, for this x direction this will be equal to m into ax, and in the y direction this will be equal to m into ay. Okay, and this is by Newton's second law of motion. Newton's second law of motion, we know that we can write that the net force acting on body is equal to rate of change of angular momentum or linear momentum. Okay, this is the Newton's second law of motion. Now if we see this equation of motion in the rectangular component, so it will have two forces in the x direction, in the y direction. Okay, so you can say that the net force is equal to max, and in the x direction, in the y direction, this is equal to may. And by the D'Alembert principle, we can also write the equation of motion. This will be equal to summation of x plus minus max equal to 0, or summation of fy plus minus may equal to 0. Okay, now since this force is the external force acting on the particle, okay, and this force is the inertial force acting on the particle, and this is called D'Alembert principle. Okay, D'Alembert principle. So we can say this is the net force acting in the x direction, which is the sum of the external force, the inertial force. So we can say that the net force in the x direction is equal to 0 and the net force in the y direction is equal to 0, provided that this net force in the x direction is the sum of the external force and the inertial force. Okay, now if we say there's motion, equation of motion in the tangential and normal component, so as we have studied that when the motion is taking place along a curved path, okay, so the motion of the particle can either take place in the straight path, that is called rectilinear motion. So it will have two components of forces as well as acceleration in the x and y direction. So when the motion of the particle is taking place along a curved path, okay, so then it will have two components. One force will be acting on a tangent to the curve, another force will be a normal force. Okay, so it will have two components of forces when the motion is taking place along a curved path. Similarly, it will have two acceleration, one in the tangential direction, another is the normal direction. So we can also write the equation of motion for these two components of forces. Ft is minus mat equal to 0 and summation of Fn plus minus ma n equal to 0. Okay, this is by D'Alembert principle that we are writing equation in this form. Otherwise, it is very simple by Newton's first law of motion, second law of motion, sorry. This will be equal to mat and normal force will be equal to man. Okay, where this tangential acceleration will be equal to, we have studied it in the kinematics, that this is equal to del v over del t. Okay, and this will be equal to, normal acceleration will be equal to v square over r, where r is the radius of curvature. Okay, now we have seen how to in kinetics we will be studying about the effect of forces, okay, that cause the motion, also the causes of the forces. That is, the cause of the motion is the force, that we have studied that it is equal to product of mass into acceleration. Now if a particle is subjected to a force F, and now this particle is displaced by some infinitesimal displacement, okay, so in the kinetics along with the forces, we'll be also studying about the work and energy. Now work in this particle, if the particle was moving, suppose this was the particle and some force is acting on the particle, okay. Now due to this force, if the particle is displaced to some distance, displacement of ds, okay, so the net force acting, net work done by the particle will be equal to F into ds cos theta, or this is not theta, this will alpha. Alpha is the angle between the force and the displacement, okay, or this is the force in the direction of the displacement. Okay, the force in the direction of the displacement will be equal to F cos alpha, where the displacement is ds. So the net work done by the body or the particle will be equal to F into ds into cos alpha. Okay, now if this particle is having the displacement of the particle is changing from S1 to S2, then this work will be equal to, one W12 will be equal to integration of F cos alpha, and this will be integrated from ds. Okay, this will be the net work. This is how you can find the net work due to displacement, okay, which is equal to F cos alpha into ds. Okay, now by the principle of work and energy, as you know, the energy is the capacity to do work, okay, and this energy, and in case of engineering mechanics, for the motion of the particle, it can basically, when the particle is moving, then it is kinetic energy. Okay, so if a particle is moving, then the energy possessed by the particle is the kinetic energy. So the energy due to motion is called kinetic energy. So principle of work and energy, and we have seen that if the particle is given some displacement, so the work which is done by the particle is equal to force into displacement. Okay, so the principle of work and energy says that work done by a force acting particle during its displacement is equal to change in the kinetic energy of the particle during that displacement. Okay, so this is called principle of work and energy. Okay, and from this principle of work and energy, you can find the displacement, velocity and acceleration. Okay, by equating this work, which is equal to F into ds, which will be equal to half of m v2 square minus half m of v1 square, and where v2 and v1 are the initial final velocity, okay, or final initial velocity, and s is the displacement. So after finding a displacement velocity, you can easily find the acceleration or the force. So this is how principle of work and energy can help you to find the value of displacement and velocity and acceleration. Okay, if the acceleration is not given, then also you can find the velocity. This is the good thing about this principle of work and energy, that if you know the displacement and velocity, initial final velocity, then you can easily find the velocities without knowing the acceleration. Okay, now till now we have studied about the kinetics of the particle. Okay, if the particle is moving, then the equation of motion was given by F is equal to ma. Okay, now as we have studied in the kinematics of rigid body, that for a rigid body in motion, it will have two motion. One is translatory motion, other is a rotatory motion. Okay, so translatory motion is further classified into rectilinear translatory or curvilinear. Okay, so we have seen the equation of motion. If we have seen equation of motion for this rectilinear motion, okay, this is summation of fx minus ma ax equal to 0, or summation of fy minus ma y equal to 0. And we have also seen for curvilinear motion, equation of motion is given by summation of ft minus, plus minus ma t equal to 0, or summation of fn plus minus man equal to 0. So these were the equation of motion for the translatory motion in rectilinear and curvilinear motion. Now, if we consider the motion of a rigid body, okay, when the rigid body is moving, then along with this translatory motion, it will have a rotatory motion also. Okay, so we know that the equation of motion for the translatory motion is given by summation of f is equal to ma, which is by Newton's second law of motion. So if the particle is also having rotatory motion, then this equation of rotatory motion is given by m is equal to I into alpha. Okay, where m is the moment, I is the inertia, moment of inertia, and alpha is the angular acceleration. Okay, so we know that if the particle is having some rotatory motion, if the body is having rotatory motion along with the translatory motion, so the equation will be equal to m is equal to I alpha. Likewise, for translatory motion, it is equal to m into a. Okay, so this is the correlation between a translatory motion and rotatory motion. Now let us see what is the relation between translatory and rotatory motion. Suppose this is a right circular cylinder, okay. Now this right circular cylinder is rotating, having some angular acceleration of alpha, and this is also having a translatory acceleration in the x direction, which is equal to ax. Okay, that is, it is having both rotatory motion and as well as translatory motion. Also, this weight is acting at the center of gravity, which is equal to mg, and there is also a reaction force and a force of friction. Okay, now there will be two cases. First case is that the particle will roll without slipping. When the body will be rolling without slipping, so in that case, the angular velocity will be equal to, the angular acceleration will be equal to alpha into theta. Okay, and this In this case, when the body is rolling without slipping, then in this case the force of friction will be less than mu into r. Okay, so this is the condition where mu r into r is called, r is the normal reaction and mu is the coefficient of friction between this body and this horizontal surface. So when the body is rolling without slipping, in that case the friction force will be less than the maximum value of the mu, coefficient of static friction, which is equal to mu into r. Okay. Second case is that when the body will be slipping without rolling. When the body will be slipping without rolling, in that case the force will be equal, friction force will be equal to mu into r. In this case the body will be slipping without rolling. And the third case is that slipping and rolling both. Okay, body will slip and roll, then in this case this will be independent of each other. Independent of each other, both the motion slipping and rolling will be independent, and this case F will be equal to mu into r. Okay, so these are the three conditions when we equate the translatory and rotatory motion of a rigid body, okay, together. Now there is also an analogy between rectilinear motion and rotatory motion. If we see the displacement is represented by symbol x, okay, in case of rectilinear motion and as unit of m. But for rotatory motion, this is represented by theta, okay, and the unit of displacement, rotatory displacement is radian, okay. If we talk about velocity for rectilinear motion, it is given by dx over dt, okay, rate of change of displacement, where x is the displacement and the unit is meter per second. If we talk about the rotatory motion, it is given by angular velocity. This is equal to rate of change of angular displacement and the unit is radian per second. Acceleration is given by del square x by del t square, unit is meter per second square, and this is equal to del square theta by del t square and the unit is radian per second square. If you talk about the mass moment of inertia, so this is unit is having mass or m, which is having kg, and this here the moment of inertia is having unit of kg meter square. Okay, so we know that in rectilinear motion equation is F is equal to m into a, and here it is equal to m is equal to I into alpha. So here m is related to this I. Okay, that is this mass of the body in rectilinear motion is equated to mass moment of inertia in case of rotatory motion. Okay, so we are just drawing a correlation, or we are drawing an analogy between rectilinear motion and rotatory motion. Okay, now if we talk about the effort, okay, since we are talking about the kinetics of the particle and body, so if we talk about the effort, so the effort is force and torque, okay, that is the cause of motion. So in this case the force is equal to m into a, which is m del square x by del t square, and here this is torque is equal to I into alpha. Okay, so here is this torque is equal to I into alpha. Next is inertia. Inertia force and couple, there will be inertia is equal to minus ma, couple will be equal to minus I into alpha. Momentum, linear momentum is equal to m into v, and angular momentum is equal to I into omega. Kinetic energy half mv square, and in case of rotatory motion it is equal to half I omega square. Okay, work is f dx, integration of dx, it is t into d theta, and this is all about analogy between rectilinear motion and a rotatory motion. Okay, always remember that equation of motion for a kinetics of a particle and rigid body is equal to F is equal to ma for rotatory motion, and torque is equal to I into alpha for rotatory motion, where T is the torque, I is the moment of inertia, okay, and alpha is the angular acceleration. Here it is force, mass and acceleration. Okay, so this is all about the kinetics of particle and rigid body. Okay, so only thing that matters is that you should remember the equation of motion, which is F is equal to ma, or torque is equal to I into alpha. Okay, so you will be using those equations for motion to solve some questions, which will be solving later in the video lectures. Okay, so this is all for today. Thank you for listening. Have a nice day. Thank you.